And welcome back to Flexible Games, where we are continuing our massive, epic journey of GUI creation for vintage story modding. It has been a journey. It has been almost 2 weeks of pounding at this thing to get it to work, and we have gotten it to work. It's glorious. I want to say it's glorious getting something like this working. I can't even describe the sense of accomplishment I got after getting this working. I mean, it's for me, it is, you know, when you figure something out, when you're programming and you pound on something and you just know that the answer is right, it's right on the other side. And you finally get to it and you finally reach it, and it's like, there it is. It's the greatest feeling in the world once you have solved whatever it is you are trying to solve. So today is going to be, I think, the last of the big GUI parts of the code, part of the tutorials, because we are getting into a very, very advanced thing today. I know last episode was really long, but it is essentially how to build a GUI from start to finish, all of the components that are involved, and there's a little rant at the end, but you know, it's hard not to rant about some things if you get frustrated by them. But anyway, this episode is strictly about how to draw something that updates while the GUI is open. Okay? So this is the dynamic drawn elements, including dynamic text, because believe it or not, the text also changes. All right, so 2 things you want to think about. How often do you want the GUI to update? Okay, one thing to think about, that's very important. You don't want it to update in real time, because in a client server situation, especially if you're playing on a server that's located elsewhere, if you update too often, you saturate your bandwidth, and you don't want to do that. So you want to update more infrequently, but you know, frequently enough. Let's call it that. So you want to think about how often you want to update. And 2, well, I don't know. I don't know what I had in mind for number 2, but anyway, how often you want to update is very, very important. And in mine, the last redraw milliseconds, right, is what I track. Okay, because the elapsed milliseconds in the CAPI, which is the client API, so you'll see a lot in my code, CAPI and SAPI. This is client API, and SAPI is server API, right? Client API, again, only on the client. Server API, only on the server. If you're playing single player, they still both exist. The single player is still running a server with a client connecting to the server. They just happen to be on the same machine. So the separation is still valid. So the big thing, the other thing that you need to know, and I know that you're gonna look at this video and go, well, stupid, that's obvious, right? But you have to know the simulation of the machine, of the block, of the item, whatever it is only on the server. Only. That is where the rubber hits the road. The client, and I cannot reiterate this enough, the client is the rendering GUI side of things, the interaction side of things, right? If you are making a mod that looks to change something in the world, you have to basically broadcast that to the server with an underlying packet network in some way, right? The best example of that, really simple example of that I can show you here, and we covered it in very brief detail last episode, is when the GUI opens, and I just pull this up because I'm proud of it, damn it. When the GUI opens, there's that slot grid right there. Okay, the slot grid is just a thing in memory, and it only exists on the client. This GUI only exists on the client. because the server obviously doesn't have a render. It's a dumb terminal. There's no rendering on it. But the server is tracking what inventories you have open. So it knows what inventories. When you open an inventory, you broadcast that to the server. And you say, hey, server, I'm a client. I'm opening this inventory. The server says, okay, it opens that inventory into your list of inventories. And then it literally broadcasts to the client, all right, open that inventory. Okay, so if you place something in this square, you have to tell the server that something was placed in the square. Otherwise, the server doesn't know. If this is representing the inventory of the block, right, which it is, you have to map that to the inventory. And so the block entity, right, the block entity is declared as an openable container, which the biggest difference here is it has an internal inventory, right? It's forcing you to have an inventory. I specify what type of inventory, test gen inventory, right? But the thing we inherit, that's power, there it is, right here. This is the inventory. This is why, this is the openable container. It's saying I have to positively, absolutely return an inventory when this is called. And so I have to return the inventory, right? And the test gen inventory is part of inventory base. So that's the polymorphism part of code. If it's of type inventory base, then the return type in the block entity is inventory base. Even though it's my object, it's still, it's still good. So you can have complex inventories, you can have simple inventories, however you want to do that. And well, I'm sure I'll get into, the weeds of inventories later, but for now, it's a really simple, again, this is a test generator. This is supposed to be deadly simple. All right. So what happens when the GUI that's opened? Okay, so there is on player right click. This is the block entity, right? The block is actually the thing in the world, right? This is the actual thing you start with. You place the block in the world. The block, when it's placed, if there's a block entity associated with it, which is in the JSON, if you look in the JSON, you will see block entity. When you place that, it automatically creates the block entity for you, and it puts that into the world. So it generates that object for you of whatever type is referenced in the mock. So I have to register the block entity, and I have to register the blocks. But you don't have to register the GUI, and you don't have to register the inventory. At least I don't think so. At least I haven't yet. So the block is the actual thing you interact with. So this is when you right click a block, the first thing that's fired is this, right? This is the first, because you're interacting with the block. Right now, it's just a dummy block. It knows, the things that it knows is what it is. It knows the kind of block it is, right? So because it knows the kind of block it is, it knows it needs to be block test gen. It knows it's a test gen. It calls this. This sees we need an entity. And I know what kind of entity it is. It's a test gen entity because, again, we know what kind of block we are. So if it's not null, which it shouldn't ever be null, if it's null with the placed block, you've got a problem. Something is destroying your entities in the background, which is not a good thing. So as long as it's not null, because you do not want to call this on a null entity, that is an instant crash. Null checks are by far the biggest thing. But then you call gen entity on player right click. I'm literally forcing an event to fire in the entity, right? The entity is specific, okay? But you also have to understand that this is being run on the client, right? This is being run on the client. So when I get the block entity, this call gets the block entity on the client, because the client has basically, it's a synchronized world, right? The server is constantly spitting updates to the client, just constantly spitting updates. And the client is updating its the world that it has. It's updating its world from the server constantly. So when a player, if you're playing multiplayer and a player places a block and you're looking at it, the player places a block. The block, the placement routine is sent to the server. The server is the thing that actually places the block, marks the chunk as dirty. Marking the chunk as dirty broadcasts the chunk to all the players. And that's why you see the block pop into existence. Is you get that and it happens so fast, it just looks like they built the block instantaneously. But that synchronization happens really, really fast. And that's why you see them place the block. So if there's ever any lag, if you ever have somebody placing a bunch of blocks and then, you know, a second goes by and it's like they all pop in later, your server is horribly lagged. Bandwidth is being saturated because of something. Or the update tick rate on the server is slow. So something is lagging your server if that happens. So this forces the block entity to call the on right click. So if we jump into the on right click in here, right? If we're on the client side, right? So if we're on the server side, we're not getting into this. Only if we're on the client side do we toggle inventory client or dialog client. This call is part of our base class, right? The block entity openable container. Toggle inventory client dialog. That is the thing that instantiates, that creates the dialog itself. So we're passing in the player and we're passing in the function that's called when that happens. This is an event that fires. And when the event fires, it wants to call code. Well, we're just inlining the code automatically. We could have public, we could have a separate function, and then it would just call that, create dialog delegate, right? Create dialog delegate. It would just call whatever we need down there. But we just put it in line because it's a simple thing. We declare a synced tree attribute. We set dialog values, right? That sets the attributes of the dialog. Remember, the dialog is a temporary thing. The dialog only exists while you have it open, right? As soon as you close the dialog, all of those resources are destroyed. They're gone. So the dialog gets instantiated with a synced tree, and the synced tree is just something that's synced on the client and the server, the attributes. And then we set the client dialog, which again is set from the base, right? If we go up to our variables, the dialog is set, right, in the block entity. Right, so that's our dialog that we're setting, and we're saying this is a new dialog, and then we are returning the dialog. And by return, the dialog returns true or false. And that's why there's a return value on player right click, because it has to know whether or not the event was handled or not. Okay, so if the event was handled, it returns true, which sort of stops going down the rabbit hole. It returns back and says, oh, we've handled, I don't have to do any more. If you're not handled, it continues going on, which, like when you eat food, If you have food in your hand and you eat it, it's like munch, 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 eat. Okay. That is because that is a thing that's carried over multiple steps. So it's not instantly eating it, it's eating it over time. And the only way to do that is to change how the events fire. But for our sake, this is generating the dialogue, and it is returning the dialogue, and it basically fires the dialogue. Let's see if I can. We'll get into all this other stuff in a second. Anyway, so that fires the dialogue open. So once the dialogue is open, now you're in this method, and when you immediately do, because remember that new, when you say dialogue equals new, this is what you're calling the constructor. And so this is setting all of these values. It's looking at to see if it's a duplicate, right? Because there is a base dialogue block entity. It's making sure it's not a duplicate. Because there's only one. Because the block entity, remember the block entity is the thing that controls it. You're telling cappy.world.player.inventory manager.open I'm hard coding it to be open. I'm saying I want this to be open. Should always be called on both sides. Remember, this is being called from here only on the client. On player right click, API.side equals client. Because the client is the only thing that's run. It's the only thing that basically runs the GUIs. But we need to open the cappy.world open inventory. I also pass in the block entity just so I can hold a reference to what block entity the GUI is responsible or attached to. The tree, remember that we have a synced tree attribute. The synced tree attribute has an onModified. So it's basically like a shared point in memory, the attributes for the GUI, where both the GUI is keeping track. The GUI is looking at this attributes, and it's you know, however often it updates, it's looking at these attributes. Anytime those attributes change, it fires this event. And I say, when this fires, I want to call on attributes modified. So it calls that modified. And then I set the attributes to the dialogue, and then I do a setup dialogue. And setup dialogue is the thing that actually it creates. We went over this last episode. This is what all of the bounds, sets the children, sets the alignment on the screen, builds single composer, right? That compose, right? This is the thing that draws the dialogue. That compose dialogue pops up, and it already has. Remember, when we hit the X to close it, it calls on title bar closed, which just does a try close, right? And try close sort of cascades it down, and it closes and frees up all of the resources down the chain. Right? And so once we have the GUI open, now here's where the rubber hits the road. Now we have, how do we update that? Okay, so if we go back to the block entity, remember this thing is simulating on the server. It's constantly updating. So two things you're going to want. You want the from attributes and two tree attributes. So two tree attributes and from tree attributes. These functions do two things. They save to the disk. If you walk away from your base or the block, if you walk way away and the block unloads from rendering, it's saving to the disk, right? The other thing that calls these values, is when it's synced from server to client. So essentially, the server wraps up when the server, when it wants to update clients, it calls this, right? And you always want to call the base because there's a bunch of other stuff that gets built in. But it generates a packet basically from JSON. The tree attributes is just like what you look in JSON. It's just all of these attributes. It's a very set, strict record of that block, and it builds this tree attribute. So this is where you build all of the custom stuff in your block, all of the custom variables, any custom inventory, all of this stuff. You know, if you have an inventory, then you call the inventory's attributes and you tack those on, and et cetera, et cetera, et cetera, right? And so the toTree attributes is building the tree. That is sent either to the disk for storage, or it's sent to the client. The client gets the from it tree attributes and basically unpacks all of the data out of it and pushes it into the variables locally on the client. Well, remember, that triggers the tree, which is the current power, the base power, all of this stuff, right? So since we got new values from the server of you know, number of seconds, all of this stuff, we need to update the GUI. We need to redraw the GUI. So this is saying if the client dialog is not equal null, we set dialog values, right? I call this value, set dialog values, and I pass it the attributes, right? I pass it the attributes because I want to pass it the dialog tree. I'm just looking at this here. Tree equals, yeah, fuel burn time, current power. So this set dialog values and then mark dirty. Mark dirty is basically the call to redraw it. And so I set true redraw on client because I want to redraw it. So the set dialog values, we go up here, boom, set dialog values, right? I have the dialog tree object. I pass it the dialog attributes. So in C#, when you pass something like that, it literally passes the reference to it. So any changes to it get reflected in the base object. And since the client dialog.attributes is a synced attributes, any change to those attributes fires that event. So I set all of these. I set temperature, burn time, power, and current power. I set all those values, which triggers in the GUI on attributes changed, on attributes modified, and this is what redraws the GUI. This event redraws the GUI. But remember, one of the first things I said is you do not want to do this in real time because you would be redrawing this so fast. You don't need to redraw the GUI 30 frames per second or 60 frames per second. You do not need to redraw the GUI that fast. And so there's a debounce in here. There's a bouncer that basically is the gatekeeper for how often you redraw the GUI, which is set, right? It's set. I just use the base games value of 500 milliseconds. So it's going to redraw this thing twice a second. Twice a second, it's going to redraw it, which is fine. Which is why when I build the GUI, I set the last redraw to 501 milliseconds earlier. So it immediately draws it instantly. It creates it and then redraws it because the milliseconds, it doesn't bounce it out. Otherwise, you would open it and you would have literally a half a second before it redraws it. And so I set that back rather than forcefully updating and redrawing it. I just set it. So the attributes modified, this updates all of my values. It gives me that new string text, which is this text right here. You can see here's the dashes. This is what builds that text. And then the draw, this little guy right here, this is the custom draw, power drawer. This is why you name all of your elements, right? The dynamic custom draw has this name, which is this name down here. So I just make sure that nothing is null, because I don't want to just go crazy, because there could be a time when you like, right when you hit X to close the window, you could be right in the middle of drawing, and like you don't want to do that. So this grabs that element and does a redraw, right? Which calls on dialog draw. Because when I set this up, add dynamic custom draw, right? The on draw delegate with bounds right here. If you look at that, on draw, right? So when it draws, it calls this internal function on dialog draw. So this thing is what draws the gradient. Okay, this is what draws the gradient. And this is what was, it was obvious to me, and I know this episode is going long again, and I'm sorry for that. I wanted to make these tight and succinct, but this is not straightforward stuff. But once I learned how this works, then it was obvious. Then it was like, oh my God, this is so simple. But what the hardest thing that it took to learn is everything is drawn, all the coordinates, all of the offsets, okay, are from the top left. So if I were to do up here, everything is drawn from up here. And for me, this is on the right, so it's really confusing my brain. But everything is drawn as offsets. Let's try to get this. Offsets, I'm bad at this. Offsets, bad. Offsets from that corner. I'd be a bad weather person because I would be, man, I'd be doing the wrong thing. Anyway, so the confusing part, the easy part was getting the grid or getting the background done. That was the easy part because I already had the size. Remember, this element, the bounds of this element is the exact same size as the object that's being drawn inside of it. So it's 30 pixels across, 100 pixels tall. Very straightforward. I've got that code right here. Vertical bar. And this, this is likely going to change so I can actually have it a little bit more dynamic. Dynamic size, so I can change the size of it and stuff like that. But anyway, this is the code that draws the gradient, right? This is the code that draws the gradient and the thing behind it. So the first thing I do, don't mind, a lot of these are values that I don't use right now. So anyway, so what the first thing that I do, this doesn't do anything because I took these translate and scale, which I'll probably put back in once I get the dynamic setup going. But so this thing here draws the vertical bar with line width of 2, right? With stroke or fill as true. And that means when that is true, that means it fills. No, that means it's, well, let's go back. If true, then stroke. So stroke, right here. So the first thing that does is it strokes. And a stroke, I know I'm saying stroke a lot. I'll probably get demonetized. If you have a line, remember lines in an SVG have zero, there's no pixels associated with those. They're just lines. The stroke is what actually draws that. So a stroke of 2 means there's a pixel on either side of that line that gets drawn, right? So the either side of that line gets 2. If you increase that, it's just going to add more thickness to the line. and you know, it might look awful. And then the other one is the default pattern. Default pattern is just like black. That's basically what it is. Oh, my nose. Cat here. So this stroke or fill, this is important in the next step. And so what this call does is it literally, because I pass it the context, and remember the context here is relegated to the element bounds, right? It's the bounds of my element, which, you know, it's where the matrix and, you know, all that kind of stuff comes in. But anyway, so I pass into that function the context, which is the element bounds, and it draws the thing. The next step is deciding what percentage we have it filled. You know, are we 50%? Are we 10%? Are we 72%? Like, how full are we as far as the battery goes? And so I pull values from our attributes. Remember, those get updated. Those are constantly being updated. And yeah, I pull max power. I could probably save max power, you know, yeah, there's definitely savings in here that I could put in later on. So I get the current power and the max power, but because they're unsigned longs, right? They're unsigned longs, which are enormous numbers, but they're whole numbers, they're integer numbers, they're not floating point numbers. And so if I'm looking for a percent full, that is a floating point number. There's no way around it. That is, you know, if I'm 72% full, the number I get back from this will be 0.72, right? And so I have to do a line like this because the division of these is going to return a fraction. If I did this with only the longs, a fraction returns 0 every time. It will always be 0. Unless I multiplied, you know, if I multiplied the result by 100, you might be able to get that out. But I didn't want to mess with that at the time. I was just trying to get this to work. So the percent remaining, this is what was complicated. This is what confused me. Remember, it's a height of 100, which is why my math, on purpose, so my math was simple. That is what this means. The 100, that is my height. It's not meaning 100%. It means my height, right? This is my height of that object. So I have to take that height and I have to subtract how much is full, and then I have to offset it, right? So the remaining amount is what I want. So at 72% full, this calculation will give me back 28, right? 100 minus 100. Remember your order of operations. Multiplication happens before adding or subtracting. So this is literally saying 0.72. Let's call it 0.75. Make it easy on us. So 75% full. 100 times 0.75 is 100 times 0.75 is 75. I believe. Yeah. 75% of 100 is 0.7 or 75. Really easy numbers. But then I take 100 and I subtract the 75. So now I have 25, which is the amount of remaining, right? Because when you draw this thing, you don't draw it, remember, you don't draw it from the bottom up. You draw it from the top down. And so you have to offset yourself down, and then you draw it, right? So this rectangle, right, I'm drawing with an offset of 0 on the X, because remember, it's the context. It's in that very itty bitty spot. So I'm offsetting at 0, but then I'm offsetting it down the percent remaining, and then I'm drawing 30 wide, which is this, And then I'm drawing the remaining down, which is 100 minus the first value. So I'm taking that and I'm going over none, but I'm going down 25, which is the percent remaining. I'm saying width 30, but down 75, which is the percent completed, or 100 minus percent remaining. Now, if my object was 142, this would be 142. This would be 142, and this would be 142, and this would be 142. But I wanted simple numbers to start with. This is important. Clip. This clips the rectangle. So the rectangle is the thing that I've drawn here, right? It's the thing that I've drawn here. And so this clips the object based on the previous thing that I drew, because we're still in the same context, remember? Which is why this gets clipped out. These little lines get clipped out, and it only overrides one pixel going around. And then the gradient is just saying the color stop of 0 and the color stop of 1 is just where those colors are, the extents of the color. And so this color is red, and it starts at 0, and this color is green, and it goes to 1. So you have red to green. For some reason, the gradient is drawn from the bottom, the gradient 1 and the gradient 0. I don't know why it's backwards from everything else. That's another thing that was really confusing, is why the gradient is backwards. I don't know. Nor do you need, I don't know why you don't even need the gradient to be big. But what that does, that gradient is a pattern, is a source, right? Remember, the first time that we did this is the default pattern, right? Pattern. This time, we set the source to the gradient, and then we draw the thing again, the same thing. We draw it again, only it's clipped, right? It's clipped, and we do not want it stroked. So we fill it. We've already set the source as the gradient. We filled it. And the second one, default pattern, is false, which is going to use the gradient as the pattern. Because we already set the source. We don't want to override it, because that wouldn't work. That would just draw it black. We don't want to do that. But because this is the thing that gets it, because I think we can test this in a second. I think because this thing draws at 100, right? This thing draws at 100. We pass it in. It's drawn and filled. I think that's why the gradient works, I think. Then we dispose the gradient. We store it. I don't know what that does. Remember, a lot of this Caro stuff isn't documented. The code isn't documented like the Vintage Story stuff is. And then we save it, and that draws that gradient. So let's test. I have an inkling that we have a bug. Upon looking at this code, I think we have a bug. So we're gonna debug this. And this is just, remember, I set up, I think it was my second episode or maybe third or something like that. I set up how to, if anybody has any questions on how to set up their environment, let me know. But here it is in the game, test generated. You can see I even have text on the top being updated, right? And here's what it looks like. And here you can see the temperature going down. I have it set so it only generates power at 100 degrees. Yet another thing that we can override for other things and everything else. We can even have machines overheat if we want to. Like, there's a lot of different things that we could do. But this will, this is really close to being full. So it starts at 40 seconds, and I have it set to, let's see. I have it set to 10 power per second. So every time a second goes by, we should be getting 10 power. So now that we're full, right? We're full. The fuel stops, and this is another optional thing. Like I'm loading as much up in this as I can to show that all these are optional. Now the thing that I wanted to test was to see if I break this and replace it, and the thing is empty, right? The thing I wanted to test is to see if the gradient starts at red and ends at green, only it's this, you know, it's tiny, it's this thin. I think that might be a bug that I have to figure out. Let's see. As this thing gets more and more power, let's put a bunch in there. It's going to be hard to see right now. It looks like it's not. It looks like it is working. I don't see any green in there. I was worried because we set it from 0 to 1 on the gradient, but the rectangle was squished. I was worried, really worried, that it would do, you know, red and green in a tiny little thing. But it looks like because we draw the whole thing over again, it stretches that out. Because remember, we're drawing it and then we're filling it, and it's the fill that takes that. But the rectangle is what's clipping it. Yeah, that's how it works. The rectangle that we draw is what's clipping it, because we're going down and we're drawing it. We're offsetting it down, and and then we're drawing it to the end, and then we're saying clip, and then we're drawing the thing again, and I think that's what's clipping it. So it is technically drawing the whole thing, but the clip is what is doing it. So that, in a nutshell, is what's going on. And you can also see when I mouse over it, the values that I have up there. It's just it's an override. It's an override of another function. And yeah, if I save it and load in, it saves all of those values are saved because of the from and to tree attributes. That's what's saved. But when you look at the block, right? Because it's not the entity. You're not looking at the entity. You're not looking at the GUI. When you look at a block, the text that's up on the top of the screen, right, is coming off the block. So the block, get placed block info, is the thing that's called. That's what gets that text that's up on the top. And this is what's called. I get again, I get the entity that's unique to that position that you're looking at. Then I call get output text, which I put in the block entity, and get output text. This is the text that it returns. Feel free to add whatever text you want. I don't think you can add anything fancy because it's literally a string. The block literally is an override of a string. I don't think you can put anything else in there other than ASCII text. But you could get creative with, instead of being, instead of power being numbers, you could have a bracket and another bracket, and then have like an ASCII character and have it some full amount in there. You could get creative with the ASCII output. But I hope that helped everybody figure out how a custom drawn element and text is in the game and how that all works. You may have to pause it and look at the code, because the source code for the project not going to be up on GitHub for a while. I want to get a lot of these things figured out and done, because the code right now is going to be way too abstract and outdated. By the time I get to the end result, it's going to be rough. It's going to be rough. Rough code right now. So yeah, none of the code is going to be available. But if you want an example freeze frame it, look at the code, and just see how I built the GUI. That was last episode. This episode was how the attributes modified. Remember, if you don't do from tree, okay, you have to have from tree attributes to tree attributes. You have to have synced attributes. You have to have the unmodified attributes, because the client, when you place the block and you look at the block, you're looking at it on the client. It is not pulling data off the server, right? You're looking at it on the client. In order to update the client, you need the server to push data out, right? You need the server to push updates out. Otherwise, the client will just be, the machine will technically have power, but the client will report 0 power, while the machine has hundreds or thousands of power. It's the server pushing out to the client that actually updates the values that you see as a client. So you need from tree attributes to tree attributes. You need the synced attributes to be set, and then you need in the GUI you need the unmodified call, and you need all of the values that I went over for on attributes modified and on dialog draw. So those on dialog draw is only if you have like a gradient or anything like that updates per frame or depending on the machine. But on attributes modified is the thing that actually redraws the thing, and that only happens when the elapsed milliseconds minus our previously saved milliseconds is greater than 500, which means 500 milliseconds, over 500 milliseconds have passed since we last drew it. And then I reset, obviously, the milliseconds. So it only redraws every half second, which will significantly improve the performance of the game and everything else. I'm not going to get into my on burn tick. I'm not going to get into like how I do the update bouncer. I'm not going to really go over this yet, because I just got this thing working. I don't know what is final, what isn't, but it works. I mean, the code works, and it works really, really well. So, the burn tick is being run every 10th of a second. 10 times per second is being run every 100 milliseconds. And the debouncer, what I did differently from what Vanilla did, what the developers did, is I was even cheekier with it. I will show this. It's almost 50 minutes long. If you all are watching to this point, I appreciate it. Okay, so what I did differently compared to the base game is the base game when it does the constructor. Let's see if I can find it. The initialize, setup dialog. No, it's the block entity. Right, it's the block entity. Bookmarks, block entity. So in the block entity, when you initialize it, here's the initialize, it sets up 2 listeners. Right? So it sets up a on burn tick, which is what I did, 100 milliseconds, and then it sets up the on 500 milliseconds tick, which is 500 milliseconds. Big surprise. So when you look at what this one does, when I looked at this and I was just like staring at this, I was like, what this is doing is basically redrawing everything. Right? Mark dirty. That's basically, it saves it and it updates the client. That's what mark dirty does. It doesn't redraw it on the client, but it basically, when called on the server, let's see. When called on the server, we'll resync the block entity with all its tree attributes to the client, right? So mark dirty is the thing that broadcasts to the client. So this is being done every 500 milliseconds, which is essentially refreshing the client. And I was like, and it does a couple other things, but essentially it's basically when you build it outside and it starts raining, it has a percentage next double rainfall. Yeah, it has a percentage chance of putting the fire out. And that's what this does. Is it does that check twice a second. I don't need to do that on my machine. So I was like, rather than do another tick listener, which, you know, I want to try. I remember I'm trying to focus on productivity. I want to focus on like impacting the simulation of the game as little as possible while getting the most out of it as possible. So what I did is I just added an update bouncer, and I just increased delta time as this thing is running. Remember, every tenth of a second, it's updating. It's increasing based on delta time. Now, delta time is not exactly 100 milliseconds, because delta time, what I have found, is the fractional number of seconds since the last update. It's not the number of milliseconds since the last update. So this value could be 0.114. Next time it could be 0.1172. Next time it could be 0.1242. Like, you could have different values in there depending on the tick rate. And so I just add that to the update bouncer, which is a simple float. And then I determine at the very end if the update bouncer is greater than 0.5. And if it is, which means more than a half a second, at or more than a half a second have passed, then you update it. And that's what, when you saw in the game, when I was looking at the block and you saw the values changing, this is the call that's doing that. This is the call that's doing that. It's forcefully updating it from the server. Because the client, again, is just a dummy terminal. It's just interacting with the world. It's loading up the GUIs. Everything has to be communicated to the server, and the server broadcasts everything to the client. And as a warning, this, I want to see if there's a better way of doing this. This call right here to the GUI runs this modified 4 times. On attributes modified gets called after this, and then it's called again after this, then it's called again after this, then it's called again after this. So it is called 4 times. I want to, one of the things I want to investigate is whether or not I can streamline that a little bit. Like, update all the values and then boom, call it all at once. I'm hoping I can figure out a way to do that, because I'm guessing some of our machines in this mod, and if you want an idea of what this mod scope is, look back in the playlist. There are 2 streams that cover. The first stream covers the entirety of the plan in great detail. But anyway, I'm assuming that we're going to have machines that are going to have a whole lot of variables that are going to be changing. And I want to, again, try to limit the sheer amount of stuff. So the dialog tree dot set, yeah, I don't see set block, set double. I don't see a way to do that. There might be a way, depending on how the attribute tree works. You could basically fabricate a new tree and just set the tree equal all at once. I don't know, but maybe I'll ask Tyrone or something if there's a better solution to that, or if he can brainstorm a better solution to that, where basically what I would want to do is I would do something like this, and this is pseudocode. I don't dialog tree dot start update dialogue tree dot apply update, something like that, where you would be able to then build, like, you could do like dot set float, something like that, dot set int, you know, et cetera, et cetera. You do all of this sets, you know, all of these calls in one call, and then boom, at the end you just dot commit or something, and it does it all at once, and then boom, the on attributes modified gets called just once. That is what I would really want. Anyway, that's gonna do it for this episode. We went way longer than I thought we were, but I hope everybody learned something. If you have questions, if you want me to record a new episode, if you want me to stream something in real time where you can ask questions, you know, leave a comment down below. If you really want one-on-one help, I have a Patreon tier that offers a couple hours a month of my time one-on-one for help. But my time, you know, I have to put value on my time in some way. I put value on my expertise, my knowledge in some way. And so, you know, I don't think it's too much to ask. If somebody wants one-on-one help, if somebody wants a mod, you know, if somebody's stuck and they really need something, then, you know, I want to offer an ability to get over the hump and get to the finish line of something. But I you know, I have my own bills and I have food to buy, so, you know, it is what it is. But yeah, please consider being a patron. You know, even on the lower tiers, it is helpful. Just knowing that people are behind the project and in support of what I'm trying to do here. But if you need one-on-one help, even if it was just 1 month, you know, please toss me $20 and say, hey, you know, 2 hours of your time, that's $10 an hour. You know, how much do you make at your job? But anyway, I thank you all for coming by, and you know, I'll see you in the next challenge. See you in the next video or stream. So have a good one.